Today we are going to learn about mastering regular expressions in text processing. We'll explore how to effectively use regular expressions to search, modify, and extract text data. By the end of this video, you'll be able to construct and apply regular expressions to solve common text processing tasks with confidence.
Welcome to our video on mastering regular expressions in text processing. Regular expressions, often abbreviated as regex, are sequences of characters that form a search pattern. They are essential tools for text processing, enabling us to search, modify, and extract data efficiently. In this video, we will explore the syntax of regular expressions, their common use cases, pattern matching techniques, and how to apply them in various programming languages. By the end of this session, you will have the skills to construct and apply regular expressions effectively, optimizing them for performance, and troubleshooting common errors.
Let's begin by understanding the basic components of regular expressions. At their core, regex patterns are made up of literal characters and metacharacters. Literal characters match themselves, while metacharacters have special meanings. For example, the dot matches any character, and the asterisk signifies 0 or more of the preceding elements. Quantifiers like plus, question mark, and specify the number of times elements should match. Character classes, enclosed in square brackets, match any one of the specified characters, such as AZ, for any lowercase letter. Anchors are used to match positions in a string, with caret for the start and $for the end. Understanding these elements is crucial as they form the building blocks for crafting powerful regex patterns. Regular expressions are incredibly versatile and can be applied to many text processing scenarios. One of the most common applications is searching and replacing text. For instance, you can use regex to find all email addresses within a document and replace them with a generic placeholder. Regex is also invaluable for data validation, ensuring inputs like phone numbers and postal codes conform to expected formats. Additionally, regex can be used to extract specific information from unstructured text, such as extracting dates from a document. Log file analysis is another area where regex shines, allowing you to filter and extract relevant information from large volumes of data. Lastly, in web scraping, regex can be used to parse HTML and extract specific elements, such as links or headings. Pattern matching and extraction are foundational tasks in text processing with regex. Capturing groups, indicated by parentheses, allow us to extract specific parts of a match. For instance, in the pattern \D+, the numbers before and after the hyphen can be captured separately. Non-capturing groups, denoted by question mark, are used when you need to group elements but don't need to capture the match. Backreferences, such as \1, refer to previously captured groups within the same pattern, enabling complex matching scenarios. Named groups, introduced in some regex flavors, enhance readability and maintainability by allowing you to assign names to capturing groups. These techniques are widely used in data parsing, enabling precise extraction of information from complex text.
Regular expressions are supported in virtually all programming languages, but their implementation can vary slightly. In Python, the module provides functions like re.search and re.match for regex operations. JavaScript features native regex support with methods such as match and replace available on string objects. Java's pattern and matcher classes offer a robust regex API, while Ruby integrates regex seamlessly with methods like equals, tilde, and scan. Despite these differences, the core syntax of regex remains consistent across languages, allowing you to transfer your regex skills across different programming environments. Understanding these implementations helps you leverage the power of regex in your preferred programming language.
Optimizing regular expressions is crucial, especially when dealing with large datasets. Performance bottlenecks often arise from excessive backtracking, where the regex engine retries matching in different ways. To mitigate this, avoid overly complex patterns and use atomic groups *greater than to prevent backtracking. Optimizing quantifiers can also improve performance. For example, prefer non-greedy quantifiers like question mark over greedy ones to minimize unnecessary matches. Pre-compiling regex patterns, where supported, can significantly enhance execution speed, as it avoids recompiling the pattern on each use. By applying these optimization techniques, you can ensure your regex patterns run efficiently even on large volumes of data.
Troubleshooting regex errors is a vital skill for any developer working with text processing. Common syntax errors include unmatched parentheses or brackets, which can disrupt the entire pattern. Debugging tools, available online, allow you to test and refine your regex patterns interactively. Understanding the behavior of your regex engine is crucial, as different engines may interpret patterns slightly differently. Fixing unintended matches often involves refining your pattern to be more specific, such as using anchors to ensure matches occur at the start or end of a string. Escape characters, like \, can also lead to confusion. Ensure you understand which characters need escaping in your regex environment. Mastering these troubleshooting techniques will help you resolve regex issues effectively. In real-world data cleaning, regular expressions are indispensable for tasks like removing unwanted characters and standardizing text formats. For example, regex can strip out non-numeric characters from phone numbers or remove HTML tags from web scrape data. Regex patterns can also standardize dates to a consistent format, ensuring uniformity across datasets. When extracting structured data, regex allows you to isolate relevant information, such as extracting product IDs from descriptions. Handling incomplete data is another common scenario, where regex can identify missing elements and flag them for manual review. By automating these cleanup tasks with regex, you can significantly enhance the quality and consistency of your data.
Advanced regex features like lookaheads and look-behinds allow for more sophisticated pattern matching. Lookaheads, denoted as equals, assert that a string is followed by another pattern without including it in the match. Look-behinds, represented by less than equals, check for a preceding pattern. These are non-capturing assertions, meaning they don't consume characters in the string. Practical use cases include validating passwords where certain patterns must or must not be present, or ensuring specific words are adjacent in text. By mastering lookaheads and look-behinds, you can construct more complex and precise patterns, expanding your text processing capabilities.
In conclusion, mastering regular expressions is a valuable skill in text processing, offering powerful capabilities for searching, modifying, and extracting data. We've covered the basics of regex syntax, explored common use cases, and delved into advanced features like lookaheads and look-behinds. Remember, practice is key to becoming proficient in regex, so take the time to experiment with different patterns and scenarios. Continuous learning is essential, and plenty of resources are available to deepen your understanding. Thank you for joining us in this journey, and we hope you feel empowered to apply regular expressions in your text processing tasks with confidence.